Hey everybody. So today we are working on this paper that says Practice on Quadratic Applications, and we're going to work on this paper for the next 3 days. Okay? So my goal today is to get through question 1 and 2 with you and then have you try one finally. So I haven't let you try one yet, so I'm anxious to see if you're understanding and how you do. All right, so this is everything I talked about last week. We're solving everything with the calculator. So number 1, an object that is launched from the ground takes a path that can be described by this equation, where f of t is the height in meters at time t seconds. Okay, so today f of t is representing our height, whereas last week it was just an h that represented height, but today it's f of t. And remember, this is our y value, because that's normally where the y is. And then this t is time, but that's typically where our x would be located. So in a second, I'm going to put it in a calculator, and I'm going to use x's. Okay, so question A says, how high is the object after 3 seconds? So is 3 seconds height, or is 3 seconds time? It's time. So I just need to know where to look in the table. Well, time are my x's. So I'm going to look in the table in the x column at the 3. And when I look there, I'll know my answer. Okay, so we need to type this equation into our calculator. So I am going to first pull up my graphing calculator. I'm going to go ahead and go zoom 6. So zoom here in the middle, and then number 6. This puts it back on a standard window. I'm going to hit enter. Okay, now I'm going to go to y equals, and I'm going to change my equation. So I'm going to get rid of that. So what do we have? Negative 6x squared. So negative 6x squared. So negative 6x squared. And then plus 36x. Plus 36x. All right, so plus 36x. And then I'm going to go straight to my table. So second graph. Oh no! What did I do? Uh-oh. This is not a negative. This is a minus. So I need to come down here to the negative. There he is. Now he's a negative. Okay, so now I'm going to go to my table. So second graph. And I am looking for 3 seconds. So I'm looking for an x value of 3. And here he is. And when I look across, this would be my y, which is my height. So after 3 seconds, the height is 54. So 54 is the winner. So 54 meters is how high it is after 3 seconds. Okay, question B. After how many seconds will it be 30 meters high? Well, is this height or is this time? This is height. Okay, and height is where the y typically is. So I'm going to be looking for a 30 in the y column. So I'm going to go and look in my table again for a 30, but in the y column, and that's because this is height. All right, do you see a 30 in the y column? Yes, here it is at 1 second and again at 5 seconds. So at 5 seconds, the height is 30, and at 1 second, the height is 30. So I have 2 answers, 1 and 5. And remember, 2 answers make sense because as the object goes up, it also comes down. So we can have a height of 30 meters on the way up, and we can have a height of 30 meters again on the way down, which could very well be 1 second and 5 seconds. Okay, C says, when will it hit the ground? Well, when an object hits the ground, I know the height is 0. So let's look for a 0 in the y column, because y is representing height. Okay, this one we don't want because at 0 seconds, nothing's happened. So let's look again, and here it is. After 6 seconds, the height is 0. So that's when it hits the ground, is at 6 seconds. And if I hit graph, I can see right there, that's when the object is going to be at the ground, which is 1, 2, 3, 4, 5, 6. So it is a 6. So it takes 6 seconds for the object to hit the ground. Okay, D says, when will the object reach its maximum height? And then the maximum height is what? Remember that maximum height is the vertex. So anytime you want to know about the maximum height, you need to find the vertex. All right, so let's look at my graph. I cannot see that vertex, and I need to see him. So for the third day, we are going to go to this button that says window. And if you want to see higher, you need to go to Y max. Now, I'm just playing with numbers here, so let's just try a 50. That's what I tried the first day. Let's hit graph and see if it works. Okay, not good enough. Okay, let's go back to window. And day 2, I did 100 here instead. So I'm just going to do 100 again. And hit graph. I need to be able to see the vertex, and as long as I can see it, I'm good. All right, this is a maximum, so let's go to calc. So second calc or second trace, however you like to say it. So second calc, I want to go to number 4, maximum, hit enter. Left bound, get Mr. Blinky cursor to the left of the vertex. He is to the left of the vertex right now, so I'm going to hit enter. Right bound, get Mr. Blinky to the right of the vertex. He is now to the right, so hit enter. And guess, get Mr. Blinky cursor right where it looks like the vertex is, and hit enter. And this looks like it would be 3, and this looks like it's 54. So 354. Okay, so 354. Now, this is the X, and X, remember, is the time. So when it says, when will it reach its maximum height? That's going to be your 3 seconds. This is the Y, and Y is your F of t, or height. So this is the height. So when it says the maximum height, that's the 54. Okay, now we're going to do reasonable domain and range. So the ball goes up, 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 and down, 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 down. So at time 0, remember the x-axis is time. So when we go to do domain, we're talking about x's. So we're talking about time. So we have time 0, because we can't have negative time, until the ball hits the ground. And how long did it take for the ball to hit the ground? Here it is. The ball hit the ground at 6 seconds. So the ball goes from time 0 to 6 seconds, because that's when it's on the ground. So time is between 0 and 6, and the symbols always go like this. Okay, range. Range is about your height. Range are your Y's, and our Y's are talking about our height. Well, what's the lowest height of the ball? The lowest height of the ball is 0, because that's what it is when it's on the ground. And then what is the highest height that it got to? Do you know what it is? The maximum height is 54 meters. So the highest height is 54. So it's somewhere between 0 when it's on the ground to its highest point, which is 54 meters up. And then the symbols always go like that. What do you think? Is it getting easier? Do you like it? All right, this one. I have a few less questions, so maybe this one will go faster. Jason jumped off of a cliff into the ocean while vacationing with some friends. His height as a function of time could be modeled by this equation, where h of t is the height in feet at time t seconds. All right, so this time h of t is my height, which remember is our y, and t, which is time, is represented by x. Okay, so question A jumps right to it. It says, how long does it take for Jason to reach his maximum height? And the maximum height is what? So remember, when he is jumping off of this cliff, he's going to go a little bit up into the air when he jumps, and then he's going to go down, 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 until he hits the water. And so he's up on a cliff, he jumps up, gets a nice little dive, and he goes down until he hits the water. So I want to know, when does he get that maximum height? So that's our vertex. All right, so let's put that equation in our calculator. So first I'm going to clear this. I'm going to go zoom 6. Yeah, there it is. All right, I'm going to go to my y equals to put my equation in. I'm going to get rid of that. So I've got negative 16x squared, and that does need to be a negative, so down here. So negative 16x squared, and then plus 16x, so plus 16x, and then in the back, plus 480. So plus 480. Okay, I'm going to go straight to looking at the picture because I want to find its vertex. And I cannot see it. All right, so I'm going to go to Window. And if you want to see higher, you want to change to Y max. Now, the highest I've done before is 100. I have a feeling this is not going to be high enough. So let's look. I'm going to hit graph. It is not high enough. Now, this 480 is a pretty big number, so I'm going to go higher than 480. So I'm going to go Y max, and I'm going to try 600 and hit graph. And you just play with numbers until you find it. Okay, so my vertex is a maximum, so let's go second calc. I want number 4 max, hit enter. So I'm going to get my blinky cursor to the left of the vertex, hit enter. Right bound, get Mr. Blinky to the right of the vertex, hit enter, and guess, get Mr. Blinky right where it looks like the vertex is, hit enter. 0.5, 484. 0.5, 484. Okay, so we had 0.5, 484. All right, so this 0.5 is the x. And remember, x is your time. So it's going to take 0.5 seconds, half a second, for him to get to his highest height. And then this is the y, and y is the height. So his highest height is 484 feet. So he jumps off the cliff. Half a second later, he's hit his highest height, and then he comes down until he lands in the water. And that's your water down there. Okay, B says, how long does it take for him to hit the water? Well, that's when your height is going to be 0. Okay, so let's go to our table and look for a height of 0. So to the table we go. Second, graph. And do you see it? Here it is. It's going to take 6 seconds for him to hit the water. Okay, 6 seconds it is. All right, now it's wanting reasonable domain and range. Okay, so he's jumping off of his cliff and he's landing in the water. Now remember, domain are about x's. And in this problem, your x's are your time. So time cannot be negative. So time is going to start at time 0 until he hits the water. How long did it take for him to hit the water? 6 seconds. So his dive lasts from 0 seconds to 6 seconds because 6 seconds is when he hit the water. And then the symbols always go like this. Okay, now range. These are y's, and our y's are talking about height. So when he hits the water, his height is 0. But how high did he get? What was his highest height? The 484 feet. That was the highest height that he got to when he made his little dive. And then the symbols always go like this. Is it getting easier? Okay, so I am asking you to do a problem for me this time. Okay, so we have to work a little bit today. So I want you to try number 3. It's about a toy rocket. Okay, you get to do it all with the calculator. So you just have to know what buttons to push, and you have to do a little bit of understanding. So you could go back and look at any notes that you might have taken or rewatch part of my video. But I want you to try number 3, and then after you do it, take a pic and post to Canvas. And that's all for today. Smile. Smiley face.